Hey everybody, Kochiro here with RC Culture. I wanted to start off by saying thank you to Axial Racing for sharing our last video on their Facebook fan page. Because of that share and many others, we finally reached 100 subscribers and nearly 5,000 views. So thank you very much to everybody who's been watching. I hope you enjoy it, and I hope to bring you many more entertaining videos. As you saw in our last video, it's finally winter here in Sweden, and we finally got some snow, and so we had an adventure out in the snow. Now, you saw my Toyota Tundra Alaska Rescue themed Axial SCX-10 in that video. I'll throw a clip of it right here. And shortly after this clip, the motor actually burned up. It was probably caused by something that shorted across the poles in the motor. A wet twig can actually do that in the right circumstances, so maybe some snow melted, got a twig wet, and it shorted the motor. This caused the commutator to burn up, and it smells like, well, like wet paint, basically. So today we're going to be hopefully restoring my Tekin 35-turn crawler motor, and I'm going to show you some tools and some techniques to do that. Okay, so here we have my Tekin T35 heavy-duty crawler motor. It's a 35-turn motor, and I use this with the Tekin FXR Pro. Now, I've talked to a few people recently who just didn't have any knowledge yet on the various components of a brushed motor, so let's go over those first. What we have here is our can, and we have our output shaft, and this is where you have one side that's slightly flattened, and that's where you run your grub screw or set screw through your pinion gear, and it touches down on this flat surface, and that's how it holds tight. Now on the other end, from this line here upwards, we have our end bell. And on our end bell we have a couple of things. First off, we have two brush hoods on either side. We have two spring posts on either side, as well as two springs. And we have two brushes. So obviously we have a positive and a negative side to the motor, and that's why we have two of everything. I used to do a lot of RC racing, and I picked this tray up from Acrotech Racing for rebuilding brushed motors. And as far as I can tell, they're not in business anymore, or at least they're not making this plate anymore. This was a CNC machined plate. It's just aluminum with some laser etching and some magnets placed in it. But what it does have is a spot for every single thing that we have to do with this particular motor. So when we're rebuilding, we've got a spot for our pinion, a spot for our cover screws, our mounting screws, our end bell screws, any other miscellaneous screws. We have a space for end bell washers, a space for can washers, a space for the positive and negative springs, the positive and negative brushes. We have an indentation for our locking ring, a hole for our armature, an indentation for our can, and an indentation for our end bell. Now, something like this isn't necessary at all, but it just makes it really nice and easy when you're doing a lot of racing with a brushed motor. It just makes all the difference in the world because everything has its place, and it makes rebuilding so much faster. Okay, so the first thing we want to do to start disassembling this motor is we're going to push on the top of this spring here. We're going to push it inwards, and we're going to lift it up, and it rotates out. And then we can lift it off of the post, and there's another end here that goes underneath the brush wire and the brush itself. And you can see that little hook there. That little hook is what keeps the brush inside the brush hood and keeps pressure on it against the commutator inside that we'll see in a moment. So we'll put this on our post, and we're just going to pull the brush out. We don't need to take it out all the way, but I'm going to just so I can show you guys what a brush looks like if you haven't seen one before. And here it is. Now, if I bring this in closer, you'll see this one's actually pretty grimy. And that's because, as I said, the motor is burned up. So now let's take off our spring on the other side. We'll put that on our negative side. And we will pull out our brush, take a look at that one. And again, as you see, it's pretty grimy, and this one actually even has a little chip out of the corner. That's okay. Now, the next thing we're going to do is take off the end bill. And we have two screws on either side, one here and one here. So we'll take those out, and then we'll be able to pry off the end bill. Now, if we take a look inside the end bell, we're going to see a couple of things. First off, you can see our brushes actually come through here and here and make contact with the commutator, which sits in the middle. But the other thing we can see is how many washers or spacers we have and what order they are in the end bell itself. So we're going to put those down on our end bell washer section. And if we take a look, we can see there actually is a there is a bearing in the end bell. Now, if this was a stock racing type motor, there'd be two major differences. First off, the can itself would not be perfectly round. There'd be a flat spot on one side, and typically this would not be a bearing, it would actually be a bushing. So let's set this aside. We're going to take out our screws just so they don't fall out and disappear on us. We'll put those on the end bell slot, and we'll put the end bell in its spot. Now, if we take a look at our can, we can see the armature sitting inside the can, and we can see that we have a fiberglass or fiber-based washer here. We'll take that off. We'll put that on with the end bell washers. And you can see just how dirty and burned up this comm is. Now, basically everything from the bottom of these tweezers up here, this section should actually be a really bright shiny copper, and you can see as I turn here it's really pretty nasty and burned. Okay. Now, the next thing we can see inside is this metal ring here, and this metal ring is our locking ring. And if you look at the case, the can, you'll see two outward indentations at least, usually. Sometimes there's more. In this case, I think there's 4 here. And all we need to do is to rotate this locking ring until those indentations are lined up with the corresponding indentations in the ring, and then we can loop through and pull it out. Now, it is basically a steel ring, and we do have magnets in the can, so it can be a little tricky to get out. But we will put that here with our locking ring section, and then we'll take a look again inside. And what we have here is the armature, and we have 2 magnets. Now, basically what happens, and I'm going to put up a graphic here, but when the armature itself is charged with electricity, and the brushes are making contact with the commutator, it will cause this motor to spin because of a magnetic pole. So in essence, one of these segments is going to be attracted to a magnet and then pushed away from a magnet and then attracted, and around and around and around it goes. Now, we want to take out the armature completely, so we push from the bottom and then we want to pull it out. Now, there are usually washers in the bottom as well, so we want to make sure we're not tipping this upside down too much. And we will place this in the armature slot, and we'll take a look down on the bottom of the can, and we can see we have 2 magnet spacers, and way down on the bottom you can see we have 1, looks like, could be more. These can be very, very thin, but in this case we only have 1 washer. So we'll take that out, put that in place on our can washer's post. And we'll just take a look at the can overall. You can see really, really dirty in here. I can see some little bits of twigs and other things in there. We're going to clean this all up. But for now we'll just set that here. And so there we have all the components of our brushed motor. We could take the brushes themselves off of the end bell here. You'll see that there's a screw here where we can take these off. On some motors they're soldered directly to the end bell, but these happen to just be screwed in place. Okay, so I've just gone and basically washed the armature, the can, and the end bell, just so you can see the difference in, first off, how dirty they were. I could still do a lot more cleaning on this if I wanted to, but it's really kind of pointless to do more than this. In fact, you don't even have to go this far. I just did it to be able to show you guys. So there's the armature. Here's our can. And you can definitely see there's a nice shiny bearing down there. And again, our end bell, same thing. You can see the red is much brighter than before, as is the black. Now, all I did to do these was just to simply rinse them in water with a toothbrush, scrubbing a little bit. You can also clean them with a variety of different spray items. You can use a spray-based brake cleaner, a spray-based electrical contact cleaner, and just spray the motor out and sort of just shake it to get all the loose liquid out of there and let it evaporate out. That's another fine way of cleaning it. Okay, so this is the case that has my Trinity TrueLathe 3 Pro in it. These are still available. I've seen them on eBay. I'm not sure what the current price is, but you could look for them on eBay and find them. I don't know if Trinity still makes them and sells them, just because brushless motors are so prevalent now. There's not a lot of RC area that's using brushed motors. Crawlers, however, are one of them. And there's a lot of other small RC that use them, and other types of things that do use them too. So if we open this up, first off, I'll tilt it up a little bit so you can see. Here we have the lathe itself, and we'll go over that in a minute. It comes with a variety of extra containers that you can hold a lot of different things in. Here I have a spare racing motor. Here I have a spare armature for that motor. Armatures do wear out. They can completely burn up. You can completely remove the copper off the commutator. Yet again, another spare armature for that motor. And then just some various things. I have some stickers and labels and spacers and things here. Some brushes. I believe these are probably 767 brushes. Here we have red springs. These are a mishmash of stock brushes and springs that were taken off of motors like the one that I just showed you. And again, blue springs and other types of brushes. This type of racing I was doing was a stock-based racing. You had to use that type of a motor. As I said, the can on a stock-based motor, I'll show you here, has actually flat sides on it. You can see here the top side and the bottom side are actually flat. And what this does is it prevents the end bell from moving. You can actually see right here, if I bring it really close, there you go. The plastic of the end bell actually comes down into the can, and that prevents the end bell from twisting. If you're able to twist the end bell on the can itself, you can actually alter the timing of the motor. That's a very complex subject to go into right now for this video, but in essence it helps you to adjust the performance of the motor. This is just the case that the diamond bit came in. Has the company's name on it in case it ever wears out and I need to get another one. A simple black magic marker. We're going to use that to mark the COM. So let's go ahead and take the lathe out. Put the case aside. And we'll get our magic marker. Now all this lathe is, hold this up a little bit better so you guys can see, is it has an Integy 55 turn motor, which are also used as crawling motors, hooked up to a battery connector. And here we have a diamond bit. We have roller bearings here, and we're able to move the bit both in and out and left to right with this dial and this dial here. So let's get this set up. What we're going to do is we're going to take our armature and we're going to do what's called turning the COM here. So we're going to take our lathe with the diamond bit and actually cut away very, very thin layers of the copper, and hopefully there's enough copper left so that we can reuse this armature. So we take a rubber ring, we place that over the armature itself, we set the armature down into the roller bearings and stretch the rubber ring down over the adapter that's going on to the Integy 55-turn motor. And you can see here how I'm able to move the lathe bit across the surface. Okay. So I'm going to reposition here so you guys can get a better look and see what actually goes on. Okay, so we're just going to plug a battery into the lathe motor here. It'll spin up to its full speed, and it'll be kind of noisy, so I'll probably mute it a little bit during the video for you guys. First off, what we're going to do is we're going to take our magic marker and we're going to mark across the surface of the COM. That helps us see where we've been able to cut and not cut, and then we'll start cutting. Now if you take a look on the COM here, you can see we have some nice bright shiny copper here, but if I turn it a little bit, you can start to see some more areas of black. And here we have a really big black patch here. Some more black. What that means is those are the spots that actually burned up. But in addition, if you notice that the outside edge here is bright shiny and the inside edge here is bright and shiny. And what that means is that we've had some wear on this commutator, this normal wear. As the brushes press in against the commutator, they create wear in the COM itself, and COMs will wear out over time. As I said before, they're a wear item. So here we can actually see that we have a slight depression like this, if you will. A U-shaped curve from where the brush has been pressing in. So we're going to start this up again. I'm going to mark it and keep going and going and going. This is a long process to get a really nice smooth finish. So here you can see I've taken another pass at it, and we still have some blackened areas here and here. A little bit there. So we'll start it up again, we'll mark it with the marker again, and we'll take another pass. Okay, now if we take another look, we just have a little bit of black here, teeny bit there, and a teeny bit there. So we're going to take one more pass. Okay, take another look. And you can see it looks clear all the way around. So bright, shiny copper all the way through. Okay, so we can take off our rubber band. Lift up the armature, and I can show you guys what this looks like. So here you can see that the commutator is bright and shiny copper all the way around. Before we go and reassemble this motor, there's a few more things that we're going to do. First off, inside these grooves we collected a lot of material as we were cutting the commutator. Okay, so we're going to scrape those out. We're also going to inspect our wires because this motor did burn up. We want to make sure that none of these actually broke, completely severed because of burning. We don't know the exact extent of the burn, so it could have actually broken through one of these if it had gotten really, really hot. I don't think that's the case here. You may notice we have a couple of different grooves here. This particular pole has two. This has one on this end, and this has one down here on the bottom end. When an armature is assembled, first off you have your wire wrappings around, but these pole pieces are balanced so that this will spin nice and true. You can see it's even marked here, 35 turn. And so when they balance these, they take a certain amount of material out of these arms. They're quite thick here to create a proper balance. So to clean out the grooves, first off we're just going to take a scalpel or an X-Acto knife if you prefer. Just run it back and forth through there. We're not cutting, we're just using the fine point here to move the material that had fallen into there out of it. And the next thing we're going to do is we're actually going to take a toothpick and run down through here. And what we're trying to do this time, we're angling the toothpick just a little bit towards each side of the groove. And what we're doing by doing this is actually sort of burnishing the edge so that it's folded down into the groove. As we have cut this commutator, the diamond bit just goes across and it carves a swath right across here. So these edges can actually be kind of sharp, and it doesn't take much. All it takes is a toothpick to sort of bend them back down a little bit where the diamond bit might have lifted them up. Okay, and if we just take a quick look at our lathe, I can show you just about how much material was taken off. You can see there's quite a bit of shavings there. That's from this motor and one other that I've done. Okay, while I'm at it, I'm going to show you a few other little tips and tricks that I picked up over the years of racing brushed motors. The first is I'm going to show you another tool here, and it's a fairly straightforward tool, but what it is a bearing or bushing puller. So if I had determined that the bearing in either the can or the end bell was bad, or the bushing was bad, what I can do is actually use this tool to pop that bearing or bushing out. It's pretty straightforward. What I would do is disassemble the tool and put the cup back on. I would run that through the can and then tighten this end down. And as I do so, it will force the bearing out of the can nice and smooth and easy without actually causing any damage to the bearing. So I can check it, I can inspect it, or I can replace it. And the same goes for the end bell. Works exactly the same way. Now the next thing that I actually want to check is I want to check how true my alignment is in my can and my end bell and the brush hoods. So what I'm going to do is actually put the locking ring back into the can. So again, we have our can, we have our locking ring, and we just need to line up our 4 indentations, and then we twist the ring so that it's locked in place, and then we can set our end bell down in place. And we can put our screws back in. Now, the first tool that I have is basically just a center core of an armature. You can see here it's still got the flat edge where we would put our pinion gear, and otherwise it's the exact piece. So what we would do is we're going to take that flat end, we're going to hold on to that, and we're going to run this up through the bearing to where it comes just out of the top of our end bell. And we're just going to spin this and see how freely it spins. If it spins freely, seems to slide through, then we have pretty good alignment. Occasionally you'll get a motor even from the factory that may not have the greatest alignment. It might not spin nicely, it might spin a little tough. You might have to apply a little extra pressure to get it to spin. And what you can do in those cases is to actually realign it by adjusting either the end bell or the locking ring inside so that you adjust the end bell. Maybe a bearing on either end or a bushing on either end isn't fully seated into the socket. So that will cause it to be sitting off at an angle instead of being in there perfectly straight. And that will cause a problem with the alignment. But in this case, it actually seems pretty good. Now the next tool that I have is just a square bar with a hole in it. And it's actually got two holes in it, so we can measure in two different ways. It's not perfectly square. You'll see it's actually shaped exactly like a brush. And the reason for that is we run it through our brush hood. And we have several different shapes of these. But in general, we're going to run this through until our hole lines up. We'll run our center post of our armature back through and make sure everything lines up and still moves freely. Now it's not going to move as freely because the bar has a little bit tighter of a hole. But what we're checking here is the alignment of our brush hoods. These goldish colored pieces on either side are actually bolted and screwed down. So if we look at the end bell, we can see that we have a screw and we have our spring post, but the bottom of the spring post actually has a nut shape to it. So we can actually unthread this out from this gold piece and our end bell. And that means that we can actually adjust the brush hood left to right a little bit. By testing this here, we now can see that this actually has pretty good alignment, because we can slide that through. It's not extremely loose, it's not extremely tight, and we can still fit our fake armature through the middle and still get good movement there. So if you were racing weekly with brushed motors, you would typically check these sorts of things quite often. Oftentimes you would use a motor for one, maybe two races at the most before you would go through and rebuild it, clean it out, check everything again. End bells and the locking rings even can be damaged in a big enough crash. I've seen locking rings that have been just bent more than you would ever thought possible from a good crash. Now what we're going to do is disassemble this canister again. We put our locking ring back. Put our can back in, we'll put our armature back in. So we've now got everything prepped. One of the things that we could be doing that I won't do in this video, but brushes, again, are a wear item. Brushes and springs. There are two things that you can use to adjust the performance of a motor. So different springs have different pressures to push on the brush differently, whether it's harder or softer. And different brushes have different materials that they're made out of, as well as some brushes are designed to have a serration to them. You can see here on this one, There's ever so slight of a serration left to it. You can see those ridges right there. And if I pull out, let's see here. If I pull out one of these old brushes that I had from racing, you can really see these are brand new brushes. And here you can see brand new serration. So some brushes are designed to be serrated like this. There are some brushes that are designed to be perfectly smooth. The serrations will wear away over time, and there are ways to reserrate a brush, but we're not going to cover that in this particular video. Okay, so now that we've got everything cleaned, we're going to start reassembling this motor. So first off, we're going to take our armature, and we had one can washer, so we're going to put that on the bottom of our armature, the end that has the flat spot for our pinion gear. And we're going to take our can, and it's best to actually hold this upside down and put the can down onto the armature. That way the washer won't fall out. And there's a lot of magnetic force in these magnets, and they'll actually pull the armature directly into place. One of the things that we want to be testing here is actually how much end play we have. So what we do is we're going to pull on this armature and see how much does it move up and down when it's sitting in the magnetic field. Now, this motor actually has a fairly strong magnetic field, so it's okay that it's moving like this. Some motors, you'll push them up and the magnetic field will just pop it right back down into place. And by wiggling back and forth, you'll be able to tell if you have too much of a spacer, too little of a spacer. But in this case, we're actually pretty good. The next thing that we're going to put on is a fiber-based washer. So we're going to put that onto the top end, and you always need to have this in place. I have run without it occasionally, but that's only in very specific circumstances to get the absolute best performance out of a motor. Okay, but there's the fiber washer. And then we had two very, very small, very, very thin, I don't know if you can even see these, spacers. One's actually a little bit bigger than the other, and we're going to put those up on top of our fiber washer. There. And then we're going to set our lock ring back down in place. And again, we just take something pointy. I happen to have a hook shape here. This doesn't have any blade edge on it at all. It looks like a scalpel blade, but it's not. It's just a hook. And we can put that into the threads and pull it. You want to move your thread holes here, your screw holes, so that they actually line up with an empty part of the can. In other words, right here where these vents are, there's no magnet sitting behind these vents. So you want to line up your screw holes with those vents. And then we're going to place our end bell back on, and again lining up the screw holes. Hold everything in place and get everything lined up, and we can put our screws in. Now we just want to start these on each side. You don't want to go and crank one down all the way and then try to put the other one in. Let's get each one started and go back to the first one, tighten it down, go back to the second one and tighten it down. This way you get even pressure across, because again, if one side is tighter than the other, then it could cause the end bell to be sitting at an angle, which is then going to affect the angle of the shaft, because it's going through a bearing or bushing here and a bearing or bushing here. And if we have something off at an angle, it's going to cause binding, and you're not going to get the best performance out of the motor. So again, we'll check, make sure it spins good. We're also going to check for end play again by pulling on the output shaft here where the pinion goes. And we want just the tiniest little bit of play. So in other words, we want it to move just a little bit. It doesn't have to be more than what you would call a hair's width, but you don't want it to be like a noisy sound when you move it back and forth. You don't want to hear like a dunk, 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 because that's too much play, and that means the motor is actually going to not get the best performance because the armature is moving up and down inside the can. We want to try to keep it in place as best we can without any binding. Okay, now that we have our end bell reattached, we can put our brushes back into the brush hoods. And we're just going to take a screwdriver and gently push them in all the way. And then we're going to put our springs back on. And again, we start by taking the hook end, go underneath the wire into the gap, and over the spring post. And then we push the other end around and into the little loop, which hooks it in place, holds everything solidly where it's supposed to be. And then we do the same with our positive side. And everything's back in place. The last step that we're going to do is I'm going to take a little bit of bearing and bushing lubrication. So this is made by Niftech. I'm not sure if they're still around. It's some old oil I had. It's basically just the same as any other type of oil. This is a synthetic. And we're just going to put a drop in the bottom, a drop in the top, give it a few spins, and we're ready to go. I've put the motor back into my crawler, and it's going to be a little noisy because the lathe box there is empty and it's going to echo, but here we have forward, and here we have reverse. So we're all set to go for the next adventure. So the question might be, why bother? Why spend all that money on a lathe when I could just buy a new motor and throw out the first one? Well, the answer is, if I spent, say, $100 on that lathe, that's about the cost of 2 or 3 of those Tekin 35-turn motors. So spend $100 and I can buy 2 motors, or spend $100 and I can rebuild my one motor 5, 7, 15 different times, over and over and over again. When that motor finally wears out, when I can no longer turn that armature, that commutator, I can buy another armature instead of buying a whole new motor, and that's usually half the cost of a new motor or less. And even if I do have to buy one more new motor to get that new armature, that's still, again, I can rebuild that new motor 15 times or more, depending on how often it's used, depending on if it's burned up like this one did or just starts to lose performance. So it's much more cost effective if you can find a lathe and use that to restore your brushed motors than just throwing one out.